Hello, everybody. My name is Cino Bifulco. I am the director of the study program in Transportation Engineering and Mobility. This master degree is framed into the area of the civil engineering, but as we will see in the next minutes, it is characterized by a great level of multidisciplinarity. The master's degree is related, of course, to transportation engineering and is intended to give to the students all the theoretical and practical tools to deal with the sector of mobility, which is a very, very active sector, increasing in importance and increasing in technological aspects. Before moving on with the presentation of the master degree in transportation engineering and mobility, let me show you some figures that relates to the economic footprint of the sector in Europe and in Italy. For instance, take into account that transportation in Europe means that we deal with millions of companies that work in this field. And this means also millions of employees. The added value to the European gross domestic product is about 15%, which is a terrific amount that has no comparison with other sectors. The turnover is of 3,000 of billions per year, of course. Um, Modes that compose the transportation sectors are road, railway, air, waterways, intended in vehicles, infrastructure, and services. In this set of modes, 80% of passengers travel by road, which is so the most important mode in transportation, and 50% of freight is moved by roads. This is an indicator of the relevance of the road sector, but also an indicator of some tricky aspects because road transportation for both passenger and freight is not the more sustainable way to move and transport. For what relates to the transportation infrastructures, so infrastructure are one of the aspects of a transportation system, is the more physical, let me say, aspects. For what relates transportation infrastructure in Italy, takes into account that 91% of the transportation infrastructure in Italy are roads, and while others 6.6% are railway, tramways, metros, and funiculars, and the rest, which is quite negligible of the transportation infrastructures, are related to the air or um, to the waterways transportations. So the total length of roads is many thousands of kilometers, and the total length of railways is some tens of thousands of kilometers. Uh, Ports in Italy are about 300, and airports are in Italy are 44 public airports, of course. Transportation systems are not only transportation infrastructure. A great role is played by transportation services, maybe a role greater than ones of transportation infrastructures. So moving passengers in Italy, all those figures are related to Italy. Moving passengers in the domestic trips in Italy, so the ones that remain within the Italian territory, means that a really great amount of passenger per kilometers is produced in terms of transportation services. Take into account that if one bus move one person for 1 kilometer, this means one passenger per kilometer. So what is moved on road by buses and autos, of course, also private transportations, and is a really huge amount of passenger per kilometers. This is equivalent to more than 22 millions of trips around the world. It's something like just for road is something like one inhabitant on two in Italy each year takes one trip around the world moving on the road network. If you add to the road the rail, the air, and the waterways transportation in terms of passenger per kilometers, you reach 24 million of trips around the world, the equivalent of 24 millions of trips around the world. It is not different, the importance, the relevance of the sector if you look from the freight transport point of view. Once again, referring to Italy and only um, to domestic trips, um, the amount of tons per kilometers uh, moved on the road system is uh, 104 billions of ton per kilometers. Take into account that if one truck move 1 ton for 1 kilometer, this is 1 ton per kilometers. Okay, so roads takes the great part of the transportation of freights with a modal share that is in favor of roads for 53%. So 50% of the freights are moved by roads, but while more waterways have an amount of transportation over 30%, rail is 16, air is just 100, is just 1%, 1%. Take into account that we are speaking about domestic transportation freights. So if you want to have an idea of what this amount of freight means, of moving freights means, this is equivalent to 27 million of male African elephants that each year are moved from Bolzano in the north of Italy to Reggio Calabria in the south of Italy. Okay, this is a terrific amount of things that are moved. And this is thanks to transportation services. So, given the previous figures that relates to the relevance of the transportation sector in Europe and in Italy, and so you can imagine what happens if you look on a global, on a worldwide scale, let's go understand what are some topics in which transportation and mobility engineers are involved in. This range from driving behavior, road safety, so understanding how drivers behave when they drive their car. This is, yes, of course, this relates to safety aspects in, in traffic, but it also relates to the efficiency of traffic and on the flowing on roads. Another topic relates to design and management of transportation services. We saw which is the relevance of the transportation service sector. So this means that you design how fleets of buses should behave in order to give services to people that have to move, or fleets of cargoes of for transportation of freights on other services. A relevant sector that is emerging in the last year is one of the new concept of mobility as a service, MaaS, mobility as a service. That means that intermodality, using each mode of transport in its better field of use, is the way in which we can improve sustainability. And this can happen if some mass mobility as a service operators are put in a layer between the customer, that are we as we move as travelers, and who offer and manage um, transportation services, so that each of our as customer can have his customized way to move in the best manner from its origin to its destination, employing at the best the whole offer of transportation with a great multimodal behavior. Transportation planning is a traditional, but let me say an evergreen field of experience for transportation engineers, and planning transportation networks or the transportation services means to evaluate how different alternatives to give services or to build infrastructures can have different aspects, different impacts also from the economic aspects, and to choose which is the best option. And the world is changing, is rapidly and revolutionary changing, and so we now are facing some very new challenges that are related to the CCAMs, the cooperative, connected and automated mobility. Means that cars and passengers and pedestrians and bikers and walkers are connected each to the other and are connected to the infrastructure, for instance, to the roads, and that this connection in terms of communications allows for a cooperative behavior. So no one behavior no more on an individual basis, but we can go in a cooperation each to the other thanks to the information. These are some effects. One of the terrific effects could be on the capacity of roads to increase their throughput, for instance. And another aspect that is very relevant is that this helps pave the way for the automation of the mobility.
Sono Ennio Cascetta, presidente del Cluster Nazionale Trasporti, che è un'associazione di imprese e centri di ricerca in tutti i settori dei trasporti terrestri. Oltre 30 grandi aziende, grandi e piccole aziende partecipano al cluster, da Ferrovie dello Stato, Stellantis, Itaci, Fincantieri e tante altre aziende, fino a delle piccole start-up, con oltre 30 centri di ricerca che fanno capo alle principali università italiane. Un totale di 33 miliardi di euro di fatturato, e migliaia di persone lavorano in queste aziende. E questo gruppo, questa associazione, il Cluster Nazionale Trasporti, è profondamente convinto che nel nostro Paese, come in tutto il mondo, stiamo attraversando una fase veramente rivoluzionaria di cambiamenti e di innovazioni tecnologiche e organizzative che riguardano i sistemi di trasporto. I veicoli a guida autonoma, la decarbonizzazione dei trasporti, la creazione di veri e propri nuovi servizi di mobilità per le persone e per le merci stanno cambiando e cambieranno in modo radicale il sistema dei trasporti, della logistica e della mobilità nei prossimi decenni, ma già sono in atto tanti importanti cambiamenti. Ecco, serve per affrontare queste innovazioni, questa fase rivoluzionaria, è importante che ci sia una nuova generazione di tecnici e di professionisti che comprendano e progettino questi cambiamenti. Menti giovani e aperte, in grado di pensare in modo diverso rispetto al passato, Per queste ragioni il cluster ha espresso formalmente il proprio interesse per la laurea magistrale in Transportation, Engineering and Mobility e vi aspettiamo tanti giovani laureati che aiuteranno il proprio Paese e perché no, l'Europa a partecipare da protagonista a questa nuova e importantissima transizione tecnologica.
So let's go now to the master degree in transportation engineering and mobility in terms of its framework, the structure, and how to access to it, and how are the subjects and other things that are practical and that we have well designed in order to facilitate your access and your management of the study plan during your transportation engineering and mobility degree. So there are some prerequisites for the enrollment in this master's degree, and of course the main prerequisite is to have a bachelor degree. This bachelor degree could be in one, let me say, of the engineering classes of bachelors, so civil, industrial, and information and communication technologies. Other cases, other bachelor's degree are considered on an individual basis. Another important prerequisite for enrollment is the proficiency for the English language at least at level B2. It is an international learning environment. We speak in English. There is a stimulating intercultural environment with many international students. And who comes from the transportation engineering and mobility master degree is ready, more ready than others for the global markets, and transportation is a global market. Within the master degree, we have a strong connection with the industrial and the economic stakeholders, and all the activities are also synergetic with the National Center for Sustainable Mobility. That is a very important center that has been granted with millions of euros in last few years, and we are fully involved in the activities of this national center, and we involve also the students. The center is comprehensive of 24 leading economic stakeholders in the transportation sector. We will see some of that in next slides. So this is the framework for the master's degree. First of all, let's note that we have a fully multidisciplinary approach. So this is due because of the broad range of competencies that are requested by the transportation engineering sector. So from a practical point of view, all classes of the first semester of the first year are online. Okay, you can see that here the table that relates to the first year or classes, and the first four of the rows of this table refers to the first semester, and you can see that all activities are online. This allows for a smooth approach to the course also by not ready students. I mean not ready as not logistical reader. You have not yet accommodation, or you have to finish for the bachelor, but you can subscribe to the master degree, or you cannot subscribe to the master degree, but you have few activities for terminating your bachelor, and in the meanwhile you would like to start attending the classes. So note also that the subjects of the first semesters are not propedeutic to the ones of the seconds. It means that you can enroll later. Let me say you can enroll at second semester, and this is allowed by the University of Naples because in general enrollment to the master's degree terminates in the month of March generally, and so you can enroll to the master degree and start following directly the classes of the second semesters. Um, as you can see, in the first year, there are no elective activities. Everything is mandatory. You have nothing to choose in the first year, and all the choices are concentrated to the second year. This is the table for the second year. You can see that you have 27 credits to be chosen in two short lists, one shorter and the other less shorter. In the first short list, you have to choose one option out of three, and the second one, two options out of six. And moreover, you have 15 credits that are completely for elective courses that you can choose as are autonomous choices. And 7 credits are for labs and internship, and 12 credits are for the master degree thesis. 15 credits for the elective activities can be chosen in any way by the students. It's a free choice, but of course this choice is submitted to the assessment and evaluation by the coordinator of the master degree. We have provided to the student to facilitate their choice of those 15 credits, a list of automatically approved subject. So if one of the students chooses in this list, this study plan is automatically accepted. And moreover, for the first of the tables you can see here, which is the list of the course that are supplied by the master degree itself, we also ensures the total compatibility of the timetable for the classes in the whole framework of the study program. For the other two uh, subject in the bottom list, we ensure the automatically admissibility of those choices, but we are not in condition to ensure the full compatibility with all the timetable. Um, Moreover, we have some pre-configured study plans, so in which both the 15 credits and the two choices from the short list, one option on three and two option out of six, all those choices are made by us, and so the students just have to choose a pre-configured study plan. We have three pre-configured study plan. One is smart mobility. It's more, let me say, related to the innovation. Another one is for smart planning. This is related to the transportation planning of services and infrastructure. And another one is related to resilient network. This is the more related to, let me say, the physical components of the transportation, that is infrastructures. If one of those three study plans is chosen, complementing it with 10 extra credits, so more credits, it is possible to attain the diploma supplement in smart infrastructure developer or applied machine learning. It depends on how you add the 10 extra credits. The output, the expected outcome of the learning framework is a multidisciplinary competence for a new generation of engineers that are firmly based in the field of civil transportation engineering, but have a large amount of skills in the fields of automation, data analysis, machine learning, but also information and communication technologies, electric engineering, and power management. This is the mix that the companies we are in touch with ask. You can see here the number of companies with which we have research and innovation contracts, and those are the subjects that are side by side with us in building the learning framework. The learning framework is built in order to ensure that our degree can fit the competencies of those companies.
Hello, my name is Luca, and I was the first student to enroll in and graduate from the master's degree program in transportation engineering and mobility. I chose this path because ever since I was a child, I've been passionate about transportation and felt a need to delve into the technical and operational aspects of this sector. Skills that I was able to acquire at the University of Federico II in Naples. Even before graduating, I found a job as an engineer in one of the largest public transportation companies in Italy. For these reasons and more, I highly recommend all enthusiasts to enroll in TEAM.
Well, I know that the presentation we have had is not exhaustive, so I'll leave you some useful links and references to get in contact with us. We are framed into the Department of Civil Building and Environmental Engineering. You can reach us at this department and in Building 5 in Via Claudio. It's the physical address where we hope that we can meet you in great numbers. And the links you can see here are for any issue you could have or a request for clarification. There are two faculty members that are devoted to tutoring and mentoring, Professor Giovanni Pugliano and Professor Francesco Galante, and Professoressa Francesca Pagliara for everything that is related to internationalization and applying to Erasmus and so on. And I suggest you to give a look and to search for more information at our website. And so I hope that this could be enough to convince you to enroll in transportation engineering and mobility. But now I would like to give you a supplement of information and to leave the floor to faculty members, teachers that are in charge of many of the subject you saw in the lists before. So you can go on with the presentation and have an overview of all the, or at least the great part of the subject and the activities that are into the transportation engineering and mobility program. So thank you for your attention, and I recommend you to stay on and to listen what our faculty members have to say. Thank you.
Welcome to presentation of the Positioning and Location-Based Services course. I am Giovanni Pugliano. This course will take you through the key characteristics of positioning and location-based services, providing you with the knowledge related to positioning techniques in different scenarios. The lectures will focus on real-time navigation measurements applied to mobile positioning and location-based services. All the geospatial applications in which location, proximity, and connectivity are the organizing principles will be studied. Students must demonstrate that they have learned the fundamental notions regarding measurements and methods for geodetic positioning, concepts and description of satellite positioning and navigation systems, inertial navigation, outdoor and indoor applications, location-based service technologies and issues. By applying the acquired skills, students must be able to collect, process, analyze, and utilize measurements and information for the real-time positioning of moving vehicles.
Hello, good morning. I am Professor Mario Pagano. I want to discuss to you the topics of the course Electric System in Transportation. The course is a mandatory course at the first year, first semester of the Master Science course in Transportation Engineering and Mobility. The course is scheduled in 3 main sections. In the first section, we focus on the fundamental of the electrical theory, and we recap all the main elements about technological aspect and scheme of power system. In the second part, we analyze the relation between the variable of the motion and energy and power requirement. In the last part of the course, we focus on the technological system for sustainable mobility with special regard to railway system. During this part of the course, we introduce you to simulation by MATLAB and Simulink tools. We have also seminary and laboratory activity on railway system. You can find on the web page the lecture, the note from the lecture, and the reference book. Finally, the exam consists in the first part, which is the solving a numerical exercise, and the second part, which is a discussion with the professor. Good luck to all of you. Bye-bye.
Hi everybody, I'm Stefania Santini and I'm going to teach you Systems and Control Fundamentals. The course will be held at the first year, first semester of your Master Science degree. And the idea is to provide the ability to design controllers. So algorithm able to steer the dynamics of a system in order to follow a commanded behavior. And the idea is to apply it to steer or to solve some transportation problems. So the idea is to steer the dynamics of vehicle, traffic flow, vehicular networks. The course will provide engineering knowledge in the sense we are going to apply mathematical and scientific concept to solve control problems, but also we are going to provide some knowledge of ICT solution in order to implement digital mobility or to address problems related to digital mobility, better to say. So the idea is to provide theory, methodology, and technology for the development of intelligent control algorithm and apply it to ETS problems and CCIM problems, cooperative connected automated mobility problems. We also are going to deal with software, and the idea is to use MATLAB Simulink in order not only to design a controller, but also to verify the achievable performance in a simulation setting. The professional outcomes of the course are be related to the fact that we are going to complement the traditional skills of transportation engineering with some ICT knowledge in order to tackle and solve the challenges arising from the next future digital mobility.
Good morning to everyone. My name is Giancarlo Sperli, and I am the professor of machine learning at the Big Data course. In this course, we will investigating methodologies and models of artificial intelligence in order to address different kind of tasks, for instance, clustering, regression, and classification. In particular, we are focusing on the strategies for training these kind of models according to unsupervised or supervised settings. Furthermore, to improve and to enhance the training process, we will leverage a large amount of data falling under the umbrella term called big data. In particular, we analyzed the concept of big data analytics that aims to infer from this large amount of data knowledge and information that could be used for improving the decision-making process.
Hi everyone, I'm Luigi Pariota, and I am the teacher of the course of Modeling of Transportation Systems. The course has the objective to provide students with all the knowledges that they need to correctly understand, model, and simulate transportation systems. Specifically, within this course, we will provide you with the tools that you need to correctly represent the supply model, correctly estimate the demand, the so-called mobility demand, and to understand in which way these two sub-models, subsystems interact each other. The course is fundamental for those who want to have a career in transportation system engineering.
Hello everyone, I am Giovanni Forte, and together with Stefania Stevenazzi, we are professors of course of digital maps and geological 3D models. The course exploits general knowledge of engineering geology for developing digital applications. It focuses on natural phenomena and the role of geological variable in environmental conditions in engineering design and construction. The course introduces the general concepts of geological data acquisition through in situ and remote sensing survey techniques, and provides the basics for managing and processing geospatial data with geographic information system, also creating 3D geological models. These tools will allow the students to acquire knowledge and software skills for the collection, management, and analysis of data, fundamental for planning and engineering infrastructure, and for identifying hazards and natural resources that interact with them. Thank you.
The Sustainable Road Materials course prepares the engineer for knowledge of innovative materials and technologies that are constantly evolving in the field of road paving. The course provides all the tools necessary for the identification of a secondary raw materials to replace those traditionally used in road paving, provides knowledge of the instrument and methodologies useful for the mechanical characterization, transferred all the congenial tools for design of different sustainable stratigraphic solution studies up to the environmental impact assessment using the CA method. The students who follow the Sustainable Road Materials course will have the opportunity to work in different sectors of the road engineering, such as company production plants for mixtures, or in public administration, covering various roles such as site manager, design director job, or even management roles.
The transport planning and appraisal actually deals with the principles, strategies, methodologies that underlines a sustainable planning of interventions on the transportation system, both physical, organization, and managerial, both on passengers and freight. The real novelty of the course deals with the decision maker, the whole decision-making process, where not only the decision maker, private and public, is involved, but also the analysts and designers, but the real novelty is represented by the stakeholders. So public engagement will be an important part, a significant part of the whole decision-making process. What are the employment opportunities from the traditional professionals to the new ones, such as the mobility manager, considering cross profiles, especially with the economics? And what are the job opportunities within the public administrations, public companies, private ones, professional offices, and research centers?
The course on railway and transit services aims to provide students with the knowledge and basic methodological tools necessary to analyze, design, and manage railway and transit services. Indeed, the student will analyze in depth the topic related to the modeling and simulation methodologies for public transport systems, the main aspects of the railway signaling and control system, the organizational and regulatory aspects of the public transport, the design and the optimization of public transport services, the analysis and representation of the considered design scenarios.
This course aims to provide the knowledge of the main constituents of electric propulsion systems. To understand the energy management in transportation, we will see what's inside a hybrid car. The powertrain of electric and hybrid vehicle will be studied. This includes road vehicles, but also railway systems. What happens during braking operation of a bulky train? The braking energy comes back from the wheels and it is redirected to storage systems like battery or supercapacitors. The use of power converters allows to control the energy flow, pursuing environmental sustainability goals in the incoming energy transition.
Hi all, my name is Marcello Cinque. Let me present you the course of real-time systems. So real-time systems are systems used in everyday life to control cyber-physical systems, like, for example, transportation system, vehicles that have dozens of sensors to read the real conditions of the machine and the road, etc., or smart roads. In this course, we are going to provide knowledge about operating system and programming languages to develop real-time systems, particularly in the automotive domain. And also we're going to provide the skills to design, tune, and develop real-time systems. Thank you for your attention. Goodbye.
Hello, I'm Filomena De Silva, and I'm teaching Resilience of Geotechnical Systems. The main goal of the course is the knowledge of the performance of geotechnical components involved in transportation infrastructures against extreme events that are geophysical events or hydrological events. Why? Because the failure of geotechnical components may cause the closure of road arches that may produce an effect on the whole network performance. The content of the course are useful for transportation engineers who want to become expert of infrastructure systems and managers involved in decision-making context.
Hello everybody, Cino Bifulco is speaking. I am the lecturer for the course of Transportation System Resilience, elective course for the second year students of the Master in Transportation and Mobility Engineering. It is included in the curriculum of all students who choose the pre-identified program in Smart Planning. It can also be chosen to obtain 6 of the 10 additional credits required by the Smart Infrastructure Developer Diploma Supplement. In this case, the main program chosen should be Resilient Networks. The resilience of transport networks plays a crucial role in the ability of complex transport systems to withstand or adapt to or recover from road disruptions. The causes of road disruption can be of different types and range from natural hazards such as earthquakes or landslides to the effects of climate changes, floods, for example, or other extreme events. It is also worth noting that one of the crucial causes of network failures could be the aging of the infrastructures. As an example, the motorway network of many countries, including Italy, are about to reach the critical age at which some of the key elements, bridges, viaducts, tunnels, should undergo major renovation. This could lead to widespread but controlled failures of the network links subject to maintenance or to disruptive and disastrous failures if maintenance is not carried out. In all cases, the effect of local disruption have to be analyzed at a network level. The resilience of transport networks addresses the need to estimate the propagation effects of network failures in terms of connectivity, serviceability, and accessibility of the entire transport systems, seen as a whole. Indeed, the effects of local faults can be perceived far from the source, or, in other cases, the effect is easily absorbed thanks to network redundancies. The complex and non-linear characteristics of transport networks make it impossible to estimate network effects on a local basis and require the use of analytical tools based on network theory and the application of methods typically of uncertainty analysis. Risk maps have to be transformed into impact maps with appropriate methods and non-linear transformations. Students will learn the basic principle associated to the propagation of disruption effects and to the assessment of the impacts under the different perspectives of topological connectivity, serviceability of the network, which implies taking into account of the demand that loads the network and the equilibrium between transportation demand and supply. Finally, the variation of accessibility can be taken as a measure for impact, and in this case, the effects on the distribution of activities and population in the study area are considered. Resilience issues due to infrastructure aging is increasing momentum worldwide, especially in the most developed countries, and the economic impact of the topic is increasingly relevant. Students with a robust theoretical background and practical abilities related to the analysis of the resilience of transportation system will have increasing work opportunities, mainly in public administration and road operators. Thanks for your attention. Hello everybody, my name is Cino Bifulco and I am the lecturer for the course on smart roads and cooperative driving, elective for second-year students of the master degree in transportation engineering and mobility. The subject is also pivotal in the minor program for obtaining the diploma supplement of smart infrastructure developer, as it covers 6 out of the 10 extra credits required for integrating the major program in transportation engineering and mobility. Smart roads play a crucial role in intelligent transportation systems. These roads utilize roadside perception technology, which involves sensors, roadside units, and edge computing devices to collect real-time traffic data. The goal is to enable vehicle-road cooperation and enhance driving safety and efficiency for vehicles with increasing automation levels. To this aim, smart roads integrate advanced network and communication technologies into the road infrastructure. Communication between vehicles and roads play a vital role in creating safer and more efficient traffic conditions. It contributes to prevent accidents by providing real-time warnings about nearby vehicles, obstacles, or pedestrians in urban areas. Enable faster emergency response by transmitting critical information and clearing the way for emergency vehicles, optimizes traffic flow, increase road throughput, and reduce congestion, addressing greening goals and enhancing overall road safety. Students will learn the basic principles and technologies adopted for smart roads, the smart sensing technology, and their basic functioning and performing in the characterization of traffic variables, the cooperative intelligent transportation services that can be developed adopting smart road communications. The students will be provided with the theoretical and operative tools for the estimation of the effect of smart road transformation tools, allowing test before invest analysis and assessing the benefit of implementation. The global market for intelligent transportation systems has been steadily growing, driven by technological advancements and the need for efficient transportation solutions. Depending from different sources of estimates, the global market is estimated from 28 to 52 billions of US dollars, with an expected growth rate for the investment in the sector from 8% to 11% per year in the next 10 years. The work market for transportation engineers specializing in smart road is evolving rapidly due to the increasing worldwide adoption of intelligent transportation systems and the development of smart cities and smart road networks. Working opportunities are open in the field of design, implementation, and ongoing maintenance of smart roads, and workplaces are mainly in public administration, road operators, innovative road construction enterprises, and technological suppliers and system integrators. Thanks for your attention.